Hi students, so now I'm in TIA. I configured my hardware, which is our CPU 1214C AC/DC relay, and here I will talk to you about the library, which we never talk about it. So this is the library. Click here, and you get the library. So now you are expert. You know the bit logic operation. You can assuming some of them you didn't use before, like okay, this set BF. I don't know what is it. Very simply, you can click and drag it here to here, and while clicking on it, you write F1, and so the help. Now you can see the help for F1, and you will read and understand how it is used. Okay, so then you can directly, even if the operation some instruction which we didn't use, you'll be able to figure out how they could be used. For example, reset set, assuming like if I say set or reset instruction, and you are aware, so you can change it from here to some other stuff. Also press F1 and look to the help. Also you have the block type of set and reset. You can same way press F1 and you get to the set reset flip flop and understand how it's working. And the cool thing is, for any instruction you can find here for more information and the program code to the above named example, refer to the sample library for instruction. So you can go to the sample library for instruction and you can download it from here. Okay, so if you click on this page, it will open to you the following link, and in here where you can download a library, and in this library you have lots of instruction, depends on your version of TIA you have. So if you have version 16, you can download this library. When I click on it, it will ask me about my, hopefully it will ask me because I already loaded, yeah, so it will download it because I already entered my login and password. But basically, if you don't have login and password, you create free one. It's nothing more. And here is the documentation installation manual. So then you have a library. In this library, you have a lot of examples for each and every, almost for each and every instruction. So you can save effort uh, and writing the code, directly seeing the example if you wish. So this is important library actually. That includes a lot of examples. Also it shows you how to use it. Alright. So here is the instruction on how to use it. It's really straightforward. You can go over it. Okay, starting from here. How to download this library. Basically I already did it offline. So basically what you do is you go to the library. That's what they explain in PDF. And you go to the global library, okay, not the project, the global library, and you click on open global library. When you click opening global library, where I downloaded my library to this way, so then I click to it, and then I click to my library and I open it. Okay, that's what I did, as simple as that. Then later, if you want to use any instruction, assuming, all right, assuming I want to use the SR set reset flip flop. So you are here, you go to you look at them. So you have example using graph or LAD or SCL. Okay, you know graph how it is. If you we never saw it, but let's look at it. We usually using LAD, right? Okay, let's start by LAD. You have the useful tool, basic instruction. All right, the basic instruction, bit logic, etc. Maybe I can extend it a bit, maybe. Or even if I extend, I cannot see. So then, yeah, maybe like this. All right. So bit logic, timer operation, counter operation, all of them. assuming bit logic operation, and you want to go to the set reset flip flop. So you click, drag it to the main block, okay, or to the program block where it's program. So here where you usually program our. Then simply double click on it, on the green one, and it will open for you. So then you can now simulate it, or look to the description here, press F1 and read about it, and the program is ready made for you. So you don't need to go to the instruction and drag each and everyone. Maybe this is a simple program just to execute it. Alright. So yeah, that's the cool thing about the library. Uh, you can, if you're curious, you can look to the. We basically learned LAN in this course, but you can look to the CL. Not sure if I take BitLogic instructions. We have some of them using. Okay, so you are here. If I double click, so see now you are writing it as a code. You are writing your program as a code. We didn't learn, but you have the opportunity to learn yourself. Learn it yourself. Uh, Also, you can look to the graph set. Here is a graph language, basic instruction. Well, let's consider any of them. Maybe this example. Drag to the program block. Alright, we are here, and here it is graph set program. Okay, we didn't learn basically graph set, but it's not like hard way. You have some description. Yes, so you can go over it. Okay, this is for the library. This is everything for the library. Um, you can discover any instruction that you didn't practice it before by downloading the code to your program block and work on it. Okay, now I will delete them because I don't want them. Okay, so that's how you delete your block. Alright, so now I deleted all. I have nothing, it is empty. Alright, so maybe if you're curious to know about any of them, basic instructions are really basic. Uh, Maybe conversion instruction we didn't work with it before. Program control instruction we were working with it before, right? Like the jump, for example. Let's test this program together. Just refresh your memory about the control instruction, which we already did together. Double click, it will open for me a program, and we can explore the program together. Okay. So this program, it has an input, jump. So set star to true to jump to network 3. So if it's true, so I jump to network 3, and it's called case 1, and here I do a reset for output 2. Okay, so it's normal to not showing the PLC tag, right? Because usually this came to the database. So here is the database for it. I have star 1, 3 input, and star out and 2 outputs. Okay, they came with it. So the database associated with the function, associated with your function. You know, when you add new function, that's how we do, and it's a function. You see, it's a green block. But this function contains a program related to the jump abstraction, which you know. So you don't need to rewrite the program yourself. Now, in your main, this is important. You need to take the function to your main, of course. Otherwise, it's not gonna be executed. You can have an input or you cannot, not necessary, you know. And that's everything. So then now you go and simulate your system. I already had a simulation open, but I will close it. Don't need exit. Yes, okay. So now I do my simulation because here I don't have hardware, and here we go. Everything seems fine. Then, well, basically I can do add some input, but I don't have input, so I will simply say run. I can say run from here or from here directly. So running the simulation. So it's a green. It's running. Yeah, it is. It's executed. I can go over it and basically execute it, modify to maybe monitor first, and then okay, let me minimize this. I don't need. And here you can see your full program. Okay, I hope I can see the three networks together. Alright, here you go. So now I'm able to see the three networks at the same time. If this is on, it will jump to three, to network three, right? Right click, modify to one, and it's jumping to here. Jump to this case. Why? Because now, look, if I change this, nothing will be executed. But this one is, it is executed actually. You see? So it's a green. It will reset some output. And here, if I execute modify, it will not be executed. Okay? If I remodify this to 0, if I remodify it to 0, this is when it's 1 because it was 1, so it is considered. Well, so I don't jump. Basically, the jump instruction is simple jump instruction, you know, nothing more than that. So just here to refresh your memory about, but here it's not for the sake of the jump. We did more complex problem related to the jump instruction. Here is just to show you the library, and you can look for some problem which we didn't use before, right? Maybe you can go to the library and basically I think we used all of them for the program control operation. We were working on all the instructions, right? And here we were working on all the instructions. Let me see this runtime control if these are things in which we have something in the library. Yes, you have the run control operation with some instruction. So if you wish, you want to learn them, you can look to the problem. And here, by the way, this program is simply the one that if you press F1 and you go here, you will see it is that problem. Okay, that example. Alright, so now I will take this again, I put here. Alright, and in my main program I will execute it. So now I don't want, okay, I don't want this. Maybe I can completely delete it even if you don't need it, and execute the following function. Alright, let's see inside what do I have as a program. Okay, that's the program I have inside. Maybe I can press F1 to read about it, and that's how you will learn limit and enable password legitimation, so you can read about it. Alright, and run and see how it works. So, you know, conversion, maybe it is a simple stuff which we didn't see before. You can go over it yourself, right? Maybe the conversion operation. Alright, and here is your program. You are converting from integer to double integer. You press F1 and you will see the exact same problem, and it's explained. You know, you have different example you can look at. Alright, that's it for the library. Uh, Next record, maybe we go more on the conversion operation, all of them. We already saw scale and normalization, but we can go over. Then the word logic operation, we almost know them. Maybe we can see the multiplexer and demultiplexer. Shift and rotate, we already saw them with Allen Bradley, so we can see them here. Also the extended instruction you can look for, technology, communication, should never explain. And the thing is, all you find not the basic instruction only, but also extended technology and communication. For all, you can find some examples on this slide.